Jin-Ho Park wiped the grease from his hands with an old rag. He had been doing this same motion for 28 years. Every morning he walked through the giant doors of the automotive factory in Detroit. Every morning he smelled the oil and metal. Every morning he heard the loud sounds of machines building cars. Jin-Ho was 52 years old now. His hair showed gray at the sides. His hands were rough and marked with small scars from years of working with tools. He started at this factory when he was just 18 years old, fresh out of high school. Back then he knew nothing about cars. An old mechanic named Robert taught him everything. Robert was gone now, retired to Florida. But Jin-Ho remembered every lesson. The factory was massive. It stretched across 20 acres of land. Inside, 2,000 cars rolled off the production lines every single day. Workers moved between stations. Robots welded metal pieces together. Paint sprayers coated car bodies in shiny colors. The whole place worked like a giant clock, every piece moving in perfect time. Jin-Ho knew every corner of this factory. He knew which machines made strange sounds before they broke down. He knew which robots needed extra attention. Other workers came to him with questions when something went wrong. They trusted his experience more than the instruction manuals. On a cold Monday morning in March 2019, everything changed. Jin-Ho arrived at 6 in the morning like always. He put on his blue work uniform and grabbed his toolbox. But something felt wrong. The usual rhythm of the factory sounded different. Machines that should be running were silent. He walked to the main production line. A crowd of workers stood around looking worried. The line supervisor, Marcus, was on his phone. His face looked stressed. Jin-Ho pushed through the crowd to see what happened. The robotic welding system had stopped working properly. These robots were responsible for joining the metal frames of each car together. Without good welds, the cars were not safe. The quality control team had found the problem an hour ago. Every third car coming off the line had weak spots in the welds. These cars would fail safety tests. They could not be sold. Marcus hung up his phone and turned to the workers. His voice was loud over the factory noise. "We are shutting down the entire line. Nobody starts working until we fix this problem. Stay in the break room and wait for instructions." Jin-Ho felt his stomach tighten. Shutting down the production line was serious. Very serious. The company lost $500,000 for every hour the line stayed stopped. Workers would get paid for waiting, but if the shutdown lasted too long, jobs could be at risk. He walked past the silent robots. Their welding arms hung frozen in position. He looked at the most recent car frame. The welds looked fine to his eyes, but he knew the testing equipment could find problems humans could not see. He touched the metal. It felt normal. Nothing seemed obviously wrong. By afternoon, corporate headquarters had sent an engineering team. 5 people arrived in black SUVs. They wore nice clothes and carried expensive laptop bags. Workers whispered as they walked past. These were the experts from the main office. They had university degrees and years of training. Surely they would fix the problem quickly. The team leader was a woman named Dr. Sarah Mitchell. She had 2 doctorate degrees in mechanical engineering and software engineering. Her resume was impressive. She had worked on aerospace projects before joining the automotive company. The other 4 engineers were also highly educated. They came from MIT, Stanford, and Georgia Tech. Dr. Mitchell set up a command center in a conference room near the production line. The engineers spread out blueprints across tables. They connected their laptops to the factory network. They pulled up thousands of lines of computer code that controlled the welding robots. The room filled with technical talk about algorithms, sensor calibration, and system diagnostics. Jin-Ho watched from a distance. He had no doctorate degree. He had no university education at all. But he had fixed thousands of problems in this factory. He had learned to trust his instincts. Something about the way the engineers worked bothered him. They never left their computers. They never touched the machines. They never walked the full production line to observe everything. On the first day, the engineers ran hundreds of computer tests. They checked every line of code. They analyzed data logs from the robots. They compared current performance to historical data. By evening, they looked tired and frustrated. The test results showed nothing wrong with the robot programming. Day 2 brought more tests. The engineers replaced sensor components. They updated software. They recalibrated the robotic arms down to the millimeter. Each time they made a change, they ran test welds. Some tests passed. But when they restarted the full production line, the defects came back. Every third car still showed weak welds. Jin-ho noticed something during these tests. The defects seemed to follow a pattern. They did not happen randomly. They happened at specific times. He pulled out a small notebook from his pocket and started writing down observations. What time did each defect occur? What else was happening in the factory at those moments? On day 3, Jin-ho decided to speak up. He waited until Dr. Mitchell took a break from her computer. He approached her carefully, holding his notebook. "Excuse me, Dr. Mitchell, I have been watching the tests. I noticed something that might help." Dr. Mitchell looked up from her tablet. Her eyes were tired. She had been working 16-hour days. "Yes, what is it?" Jin-ho opened his notebook. "The bad welds happen about 47 minutes after the line restarts. Every time. I also noticed the temperature gauge near the welding station changes slightly around that same time." Dr. Mitchell glanced at his handwritten notes. She smiled politely, but Jin-ho could see she was not really listening. "Thank you for your observations. We have already checked all environmental factors. The temperature and humidity controls are working within normal ranges. The problem is clearly in the robotic calibration system. We need to follow proper diagnostic protocols." She turned back to her tablet. The conversation was over. Jin-ho stood there for a moment, then walked away. His observations were dismissed. To her, he was just a mechanic. What could he know that 5 highly trained engineers did not? But Jin-ho could not let it go. He had been fixing things his whole life. His gut told him the engineers were looking in the wrong place. They were so focused on the robots themselves that they missed something bigger. Something in the environment around the robots. By the end of day 3, pressure mounted from every direction. The plant manager, Kim Tae-young, received angry calls from corporate headquarters every hour. The CEO was furious about the losses. Thousands of workers sat idle in break rooms, getting paid but producing nothing. Car dealerships across the country called asking where their shipments were. Some dealerships threatened to cancel orders and buy from competitors. Kim held an emergency meeting with all department heads. His voice was sharp with stress. "If we do not solve this problem in 48 hours, headquarters will replace everyone. The engineering team, the supervisors, maybe even me. We need answers now." The engineers worked through the night. Jin-ho saw their conference room lights still on when he left at 10 in the evening. He felt bad for them. They were smart people working hard. But being smart was not always enough. Sometimes you needed experience. Sometimes you needed to look at problems differently. That night, Jin-ho could not sleep. He lay in bed next to his wife, Sun-yi. She could tell something bothered him. "What is wrong?" she asked. "I think I know what is causing the problem at work," Jin-ho said quietly. "But nobody will listen to me. They think I'm just a mechanic." Sun-yi touched his arm. "You have fixed 1,000 problems they could not solve. Trust yourself." Jin-ho stared at the ceiling. The factory was his life. He had spent 28 years there. He knew that place better than he knew his own house. Tomorrow he would prove his theory, even if he had to break some rules to do it. Jin-ho arrived at the factory at 4:30 in the morning. The parking lot was almost empty. Only security guards and a few janitors were inside at this hour. The engineering team would not arrive until 7. That gave Jin-ho time to investigate on his own. He did not bring a laptop or fancy testing equipment. He carried his old toolbox, a flashlight, and his notebook. These simple tools had served him well for nearly 3 decades. He believed in using his eyes, ears, and hands to understand machines. Computers were useful, but they could not replace human observation. The factory was quiet without the usual noise of production. Jin-ho's footsteps echoed on the concrete floor. He walked slowly down the entire production line, looking at everything. He was not looking for anything specific yet. He just wanted to feel the space, to notice anything unusual. The welding station sat in the middle of the line. 6 robotic arms hung from overhead rails. Each arm held a welding torch. When working properly, these robots moved with precise timing, creating perfect welds in seconds. Now they stood frozen, waiting for someone to fix whatever was wrong. Jin-ho pulled out his flashlight and examined the area around the robots. He looked at the floor, the walls, the ceiling. He checked the electrical connections. He inspected the gas lines that supplied the welding torches. Everything appeared normal, but he knew appearances could be deceiving. He sat on a metal stool and just watched. This was a technique old Robert had taught him years ago. "Sometimes you need to be still and let the problem show itself," Robert used to say. Jin-ho waited and observed. At 5 in the morning, he heard a mechanical hum. The factory's ventilation system was turning on. Huge air handlers on the roof pulled fresh air into the building and pushed stale air out. The system ran on automatic timers, cycling on and off throughout the day to maintain air quality and temperature. Jin-ho felt a slight change in air pressure when the system activated. It was subtle, barely noticeable, but he had spent so many years in this building that he noticed. He looked at the temperature gauge near the welding station. It moved slightly, just a tiny fluctuation, nothing that would alarm anyone. He wrote in his notebook, "Ventilation system turned on at 5 a.m., small temperature change." Air pressure felt different. At 6, more workers started arriving. The maintenance crew came in. The line supervisors showed up. By 7, the engineering team returned to their conference room. They looked exhausted. Dr. Mitchell's eyes had dark circles under them, but they kept working, running more computer simulations. Jin-ho started his normal shift. But every 47 minutes he checked the welding station area. He wanted to test his theory. If he was right, the ventilation system cycled every 47 minutes. And each time it cycled, it created conditions that affected the welding process. At 8:47, the ventilation system cycled again. Jin-ho was watching closely. The air pressure changed. The temperature gauge showed a small fluctuation. More importantly, he noticed something near the welding robots. The shielding gas that protected the welds from contamination seemed to move slightly, disturbed by the air pressure change. Welding requires very specific conditions. The metal must be hot enough to melt and fuse together, but it must also be protected from oxygen in the air. That is why welders use shielding gas. This gas creates a protective bubble around the weld, keeping oxygen away. If the shielding gas gets disturbed, oxygen can contaminate the weld, making it weak. Jin-ho's heart beat faster. This was it. This was the problem. The engineers were checking the robots, the programming, the sensors. But the real issue was environmental. The ventilation system was creating tiny air pressure changes. These changes disrupted the shielding gas. Not on every weld, just occasionally. Just enough to cause defects in every third car. He needed to test this theory properly. But he could not just stop the production line whenever he wanted. He needed permission. And he needed someone in authority to take him seriously. Jin-ho watched the engineering team through the conference room window. They were having a heated discussion. Dr. Mitchell pointed at her computer screen. Another engineer shook his head. They were arguing about technical details Jin-ho did not fully understand. But he could see they were stuck. 3.5 days had passed. They were no closer to solving the problem. He took a deep breath and walked to the conference room. He knocked on the door. Dr. Mitchell looked up, clearly annoyed at the interruption. "Yes? Dr. Mitchell, I need to show you something. I believe the problem is not the robots. It is the ventilation system." She put down her pen. The other engineers stopped talking. They all looked at Jin-ho. He could see skepticism on their faces. One engineer, a young man named Brad, actually laughed. "The HVAC system? We checked that on day 1. It is operating perfectly within parameters." Jin-ho stayed calm. "I am not saying it is broken. I am saying it is affecting the welding process. The air pressure changes when it cycles. This disturbs the shielding gas. I have been observing it all morning." Dr. Mitchell closed her laptop. She spoke slowly, like she was talking to a child. "Mr. Park, we appreciate your input, but we have sensors monitoring air pressure, temperature, and humidity. Everything is within acceptable ranges. The welding robots have their own shielding gas regulators specifically designed to handle normal environmental variations. The problem must be in the robotic calibration system." "But have you tested what happens exactly 47 minutes after restart?" Jin-ho asked. "That is when the ventilation cycles. That is when the defects occur." "That is coincidence," Brad said. "You are seeing patterns that are not there." Dr. Mitchell stood up. "Mr. Park, we have doctorates in engineering. We have analyzed thousands of data points. We are following established diagnostic procedures. Please let us do our job." Jin-ho felt his face get hot. Not from anger, but from frustration. He had the answer. He knew he did. But they would not listen because he did not have the right degrees. He did not speak their technical language. He was just a factory mechanic. He left the conference room. His hands were shaking slightly. Soon-Yi's words from last night echoed in his mind. "Trust yourself." Jin-ho made a decision. If the engineers would not listen, he would go directly to the plant manager. This was risky. Going over people's heads could make enemies, but the factory was losing millions of dollars. His co-workers' jobs were at risk. He had to try. Plant manager Kim Tae-young was in his office looking at financial reports. The numbers were bad, very bad. Jin-ho knocked on the open door. "Mr. Kim, can I have a moment?" Kim looked up. He knew Jin-ho. Every plant manager knew their best mechanics. "Jin-ho, what can I do for you?" "I am very busy. I know what is wrong with the welding line, but the engineering team will not listen to me. I need 1 hour to prove my theory." Kim leaned back in his chair. He studied Jin-ho's face. "The engineers have been here for 4 days. They have equipment and expertise we do not have. Why should I believe you solved what they could not?" Jin-ho pulled out his notebook. He showed Kim his observations. He explained his theory about the ventilation system and the shielding gas. He spoke simply and clearly. He did not use complicated technical words. He just described what he saw. Kim listened. He had worked in factories for 30 years before becoming a manager. He understood that sometimes the simplest explanation was correct. He also knew that Jin-ho had an excellent track record. In 28 years, Jin-ho had never been wrong about a mechanical problem. 1 hour, Kim said finally. "I will give you 1 hour to test your theory. If you are wrong, you go back to your regular job and never speak of this again. If you are right," he paused. "If you are right, you will save a lot of jobs, including mine." Kim called the engineering team to the production line. Dr. Mitchell looked unhappy about the interruption. "We are in the middle of important calculations," she said. "This mechanic believes he found the problem," Kim said. "I am giving him 1 hour to prove it. You will observe and verify his test." The engineers exchanged looks. Brad rolled his eyes, but they gathered around the welding station. Jin-ho felt their skepticism like a physical weight. His hands were sweaty. If he was wrong, he would look like a fool in front of everyone. He explained his theory again. This time, Dr. Mitchell listened more carefully. She pulled out her tablet and checked the ventilation system logs. "The HVAC does cycle every 47 minutes, she admitted. "But the air pressure variations are minimal, within acceptable parameters. Can we manually control when it cycles?" Jin-ho asked. "Just for this test?" Kim called the facilities manager. Within 10 minutes, they had manual control of the ventilation system. Jin-ho asked them to keep it off during the test. Then he asked the line supervisor to start a production run. Everyone watched as the robots came to life. The welding arms moved smoothly. Sparks flew as metal pieces fused together. The first car frame came off the line. Quality control inspected it immediately. The welds were perfect. A second car frame. Perfect welds. A third car frame. Perfect welds. Jin-ho asked them to turn the ventilation system on mid-cycle. The air handlers hummed to life. 30 seconds later, a car frame came off the line. Quality control inspected it. The welds showed defects. Jin-ho asked them to turn the ventilation off again. The next 3 car frames had perfect welds. Dr. Mitchell worked quickly after Jin-ho's successful test. She connected her laptop directly to the factory's environmental control system. Her fingers moved fast across the keyboard. She wrote new code that synchronized the ventilation cycle timing with the production line schedule. The HVAC system would now avoid cycling during critical welding operations. 2 hours later, the new program was ready. They ran a full production test. 20 cars moved through the welding station. Quality control inspected every frame carefully. Every single weld was perfect. Not one defect. The problem was completely solved. Plant manager Kim called everyone to the main floor. Workers poured out of break rooms where they had been waiting for days. Supervisors, engineers, maintenance staff, and line workers all gathered around. Kim raised his voice to be heard over the crowd. "After 4 days of shutdown, our production line is fixed. Thanks to the hard work of many people, but especially thanks to Jin-ho Park, who identified the root cause of our welding defects. Jin-ho, please step forward." Jin-ho felt his face turn red. He did not like being the center of attention. He walked to where Kim stood. The crowd erupted in applause. His co-workers cheered and whistled. Some patted his back as he passed. Marcus, the line supervisor, shook his hand firmly. Kim continued speaking. Jin-ho's observation and experience saved this company over $40 million in losses. He reminded us all that solutions can come from anywhere, and we need to listen to every voice in this factory. The applause grew louder. Jin-ho looked at the crowd and saw genuine happiness on people's faces. These were his friends, people he had worked beside for years. They were proud of him. But when he glanced at the engineering team standing off to the side, he saw different expressions. Dr. Mitchell's face was neutral, professional. But her jaw was tight. Brad stared at his phone, not looking at anyone. The other engineers whispered among themselves. Jin-ho's moment of victory suddenly felt uncomfortable. He had not meant to embarrass anyone. He just wanted to solve the problem. After the announcement, production resumed. The welding robots hummed back to life. Car frames moved down the line. The familiar rhythm of the factory returned. Workers went back to their stations, relieved to be working again instead of sitting idle. Jin-ho returned to his workstation. But the day felt different now. People kept coming by to congratulate him. Some asked for his autograph as a joke. Others wanted to take photos with him. He appreciated their kindness, but it made him uncomfortable. He was just a mechanic doing his job. Late in the afternoon, Jin-ho walked past the engineering team's conference room. The door was closed, but he could hear raised voices inside. He did not mean to eavesdrop, but he paused when he heard his name. "This is humiliating," Brad's voice said. "A mechanic with no degree shows up 5 engineers from top schools. How does that look for our department?" "It looks bad," another voice agreed. "Corporate is going to question why they pay us so much if factory workers can do our job." Dr. Mitchell's voice cut through. "That is not fair. Jin-ho has almost 30 years of experience in this specific facility. He knows things we do not. There is no shame in learning from experience." "Easy for you to say," Brad replied. "You are the team leader. This failure falls on all of us. My career could be damaged because we missed something obvious." "It was not obvious," Dr. Mitchell said firmly. "The air pressure variations were within normal parameters. We followed correct diagnostic procedures. Sometimes the right answer comes from unexpected places. We need to accept that and move on." Jin-ho walked away. He felt guilty even though he knew he should not. He had done the right thing. The factory was running again. Jobs were saved. But he had also created conflict. The engineers felt embarrassed and threatened. That was not his intention. That evening, corporate headquarters released an internal report about the incident. Jin-ho's wife Soon-yi read it to him from the company website. The report briefly mentioned a cross-functional team effort that solved the welding problem. It thanked the engineering department for their thorough analysis and quick implementation of solutions. Jin-ho's name appeared once, in the middle of a long paragraph, as a factory technician who provided valuable observational input. Soon-yi put down her phone. "They barely mentioned you. After you saved them $40 million, Jin-ho shrugged. "I do not need credit. I just wanted to fix the problem." "But it is not fair," Soon-yi said. "You did the work. You found the answer. They should acknowledge that." "Corporate politics is complicated," Jin-ho replied. "The company cannot admit that their expensive engineers were outperformed by a mechanic. It makes them look bad. I understand, but he did not fully understand. Not really." He felt a strange mix of emotions. Pride in solving the problem, satisfaction that the factory was running, but also disappointment that his contribution was minimized in the official report. The next day, David Chen arrived from corporate headquarters. He was the vice president of operations, a powerful executive who oversaw all manufacturing facilities. His visit was unexpected. Plant manager Kim seemed nervous when David walked through the factory doors. David spent the morning touring the production line and speaking with various department heads. In the afternoon, he asked to meet privately with Jin-ho. They sat in a small conference room. David was in his early 50s, wearing an expensive suit. He had an MBA from Harvard and had risen quickly through the corporate ranks. "Jin-ho, I read the detailed reports about the welding incident," David said. "The official version and the real version. I know exactly what happened here. You solved a problem that stumped our engineering team. That is impressive. Thank you, sir. I was just doing my job. That is what I like about you. No ego." David pulled out a folder. "I have a proposal. Actually, 2 proposals. You can choose which one you prefer." He opened the folder and showed Jin-ho the first option. Option 1, you receive a $50,000 bonus. Cash payment. Deposited in your account within a week. You return to your regular mechanic position. Everything goes back to normal. You continue doing what you have always done. Jin-ho's eyes widened. $50,000 was more money than he had ever seen at once. That could pay off his car loan. It could help with his daughter's college expenses next year. It was life-changing money. Option 2 is more complicated, David continued. He showed Jinho the second document. We create a new position called the Integrated Solutions Team. This team pairs experienced factory workers with engineers. When we have complex problems, both groups work together. Different perspectives, combined expertise. You would be the first factory representative on this team. What would that mean? Jinho asked. It means traveling to other factories when they have problems, working directly with engineering teams, higher pay than your current position, though not as much immediate cash as option 1. You would be visible. Corporate would know your name. But you would also have more pressure and responsibility. You would need to train others to think the way you think. Jinho sat quietly processing this information. Option 1 was simple and safe. Take the money, go back to normal life. Option 2 was risky and uncertain. It meant stepping into a completely new role. It meant continued conflict with engineers who might resent him. Can I have time to decide? Jinho asked. Take until Monday, David said. That is 4 days. But I need an answer by then. If you choose option 2, we want to start the program quickly. That weekend, Jinho could not stop thinking about the decision. On Saturday morning, he sat with Sunyi at their kitchen table. She poured coffee and listened as he explained both options. $50,000 would help us so much right now, Sunyi said. We could finally fix the roof. We could help your mother with her medical bills, but what? But you would regret taking the easy choice. I know you. You care about more than money. You care about doing work that matters. Their son Ji-sung came home from college that afternoon. He was studying business administration at the state university. Jinho explained the situation to him. Ji-sung did not hesitate. Take option 2, Dad. This is your chance to make a real difference. Think about all the other mechanics and factory workers out there who never get listened to. You could change that. You could show companies that experience matters as much as degrees. Their daughter Sumin called that evening. She was a high school teacher in Chicago. When Jinho told her about the choice, she got quiet for a moment. Dad, I spend every day teaching teenagers. Many of them come from working-class families like ours. Their parents are mechanics, electricians, nurses, construction workers. These kids get told that the only way to succeed is to go to university and get a degree. But that is not true. Your story proves that experience and observation are valuable. If you take this new position, you become proof that blue-collar workers matter. You become a role model. Jinho realized his family was right. This was bigger than just him. It was about respect for all workers who learned their skills through experience rather than textbooks. It was about showing that different types of knowledge are equally valuable. On Monday morning, Jinho walked into plant manager Kim's office. David Chen was there waiting for his answer. Jinho placed the unsigned contract for option 1 on the desk. I choose option 2, he said. But I have one condition. David raised his eyebrows. What condition? Dr. Sarah Mitchell must be my partner on the first project. I want to work with her directly. David looked surprised. The engineer who missed the problem? Why would you want to work with her? Because she is smart and skilled. She just approached the problem differently than I did. If we work together, we can learn from each other. Engineers and mechanics do not need to compete. We need to collaborate. But someone has to show how that works. It might as well be us, David smiled slowly. That is either very wise or very naive. Maybe both. Okay, I agree to your condition. But I warn you, Dr. Mitchell might not be happy about this arrangement. That is okay, Jinho said. Important things are rarely easy. 3 days later, Jinho received his new assignment. He and Dr. Mitchell would travel to a paint facility in Tennessee. The facility had problems with their automated paint sprayers. The local engineering team had been working on it for 3 weeks with no success. Production quality was suffering. Jinho packed a suitcase for the first time in years. Sunyi helped him choose clothes. Remember to be patient with Dr. Mitchell, she said. She's probably still angry and embarrassed. I know. But if we can make this partnership work, it proves that the whole program can work. On the flight to Tennessee, Jinho sat next to Dr. Mitchell. The tension between them was obvious. She answered his questions with short, cold responses. She spent most of the flight working on her laptop, deliberately avoiding conversation. Jinho understood. He had made her look foolish in front of her colleagues. She had spent years earning her credentials and building her reputation. Then a factory mechanic solved a problem she could not. That hurt her professional pride. But Jin-ho also knew something important. This was not about pride or ego. This was about finding the best solutions to real problems. And the best solutions came from combining different types of knowledge. He just needed to prove that to Dr. Mitchell. And to himself. The real work was about to begin. The Tennessee paint facility looked similar to the Detroit factory, but smaller. It specialized in custom paint jobs for luxury vehicles. The building smelled of paint thinner and chemicals. Workers moved between spray booths wearing protective suits and masks. The facility manager, Robert Torres, met Jin-ho and Dr. Mitchell at the entrance. He looked exhausted. Dark circles hung under his eyes. "Thank you for coming. We are desperate. Our paint quality has been inconsistent for almost a month. Some cars have perfect coatings. Others have thin spots or uneven coverage. We cannot figure out why." Dr. Mitchell immediately went into professional mode. "Show me your technical specifications for the paint sprayers. I need to see your computer systems, calibration logs, and quality control data." Robert led them to a control room filled with monitors. Dr. Mitchell sat down and began analyzing data. Jin-ho watched her work for a few minutes. She was clearly brilliant. Her fingers flew across the keyboard. She pulled up complex charts and diagrams, but she never looked at the actual paint line. "I am going to walk the floor," Jin-ho said. Dr. Mitchell barely glanced up. "Fine. I will be here reviewing the system architecture." Jin-ho put on a protective suit and mask. He walked through the paint facility slowly, observing everything. The spray booths were enclosed rooms where robotic arms applied paint in precise patterns. Between each booth, cars moved on a conveyor system. Workers inspected each vehicle before it moved to the next stage. He stopped to talk with a paint line operator named Carlos. Carlos had worked here for 15 years. "What do you notice about the bad paint jobs?" Jin-ho asked. Carlos thought for a moment. "They seem to happen more on humid days. But the engineers checked the humidity controls. They said everything is fine. Do you notice any other patterns?" "Well, the problems seem worse in the afternoon. Morning shift usually has better results. But I mentioned this to the engineers and they said the paint system does not change between shifts. Same settings, same everything." Jin-ho wrote this information in his notebook. He spent the next several hours talking to different workers on the paint line. Many had observations similar to Carlos. They noticed patterns but had been told these patterns were not relevant. That evening, Jin-ho and Dr. Mitchell met in their hotel to compare notes. She had filled a legal pad with technical calculations. Jin-ho had his notebook with handwritten observations from workers. "The paint viscosity control system is functioning correctly," Dr. Mitchell said. "The spray nozzle calibration is precise. The robotic arm movements are accurate to within 0.01 millimeters. I cannot find any mechanical or software errors." "What about humidity and time of day?" Jin-ho asked. Dr. Mitchell frowned. "Humidity is controlled within acceptable parameters, and time of day should not matter. The robots operate identically regardless of when they run. These observations are not scientifically relevant." Jin-ho felt frustration rising. But multiple workers mentioned these patterns. Maybe the patterns mean something you cannot see in the data. With respect, Jin-ho, feelings and hunches are not data. We need empirical evidence. We need to follow the scientific method. And how is the scientific method working so far? The words came out sharper than Jin-ho intended. Dr. Mitchell's face hardened. "You solved one problem in a factory you have worked in for 30 years. That does not make you an expert in all industrial processes. Paint technology is extremely complex. It requires understanding chemistry, fluid dynamics, environmental controls, and automation systems. You are a mechanic, not a chemical engineer." The word stung. Jin-ho stood up. "You are right. I am just a mechanic. Someone who actually talks to the people doing the work. Someone who pays attention to what is really happening instead of what the computer says should be happening." He left the hotel room and went for a walk. The Tennessee evening was warm and humid. He called Sunyi. "It is not working," he told her. "She still sees me as beneath her. She will not listen to my observations. Maybe this whole partnership idea was a mistake." Sunyi's voice was calm. "You are both being stubborn. She is protecting her pride. You are protecting yours. Someone needs to be bigger than that. Why does it have to be me? Because you are the one who chose her as a partner. You said you wanted to prove that engineers and mechanics could work together. Did you think it would be easy? Jinho walked for another hour, thinking. Sunyi was right. He had chosen this difficult path. He could not give up after one argument. The next morning, Jinho arrived at the paint facility early. He found Dr. Mitchell already in the control room staring at her computer screens. She looked like she had not slept much. Dr. Mitchell, can we talk? She did not look up. I am busy, please. Just 5 minutes. She sighed and turned to face him. What? Jinho sat down. I apologize for last night. I was frustrated and I said things poorly. You are absolutely right that you have knowledge and training that I do not have. But I believe I have knowledge that you do not have too. Different knowledge, not better or worse. Just different. Dr. Mitchell's expression softened slightly. Go on. What if we stop competing? What if we combine our approaches? You have your simulations and data analysis. I have my observations and worker input. Together, maybe we see things neither of us could see alone. She was quiet for a long moment. Finally, she spoke. I was up all night analyzing paint chemistry. Every formula, every variable. The technical specifications are perfect, but the results are not perfect. I am missing something and I do not know what. Then let me help you find it. But you need to consider the observations I collected, even if they seem unscientific. Dr. Mitchell pulled up a chair. Tell me what the workers said, everything. Jinho opened his notebook. He shared all the observations. Humid days had more problems. Afternoon shifts were worse than morning shifts. Some spray booths performed better than others even though they were supposedly identical. Paint sometimes looked slightly different in color even though it came from the same batch. Dr. Mitchell listened without interrupting. When Jinho finished, she started typing on her laptop. What if we input these environmental variables into my simulation models? I originally used only the technical specifications, but what if we add real-world conditions that change throughout the day? She worked for 30 minutes adjusting her computer models. She added variables for humidity changes, temperature fluctuations, even air pressure differences between morning and afternoon. When she ran the new simulation, her eyes widened. This is it. Look at this. She turned her screen toward Jinho. The simulation showed that paint viscosity needed to change in response to environmental conditions. The current system used fixed paint viscosity settings based on the official specifications, but real-world conditions varied throughout the day. Humidity affected how paint particles behaved in the air. Temperature affected how quickly paint dried. These tiny environmental changes accumulated, creating inconsistent results. The paint viscosity control system is not broken, Dr. Mitchell said excitedly. It is just too simple. It uses fixed settings when it should use adaptive settings. We need to program it to adjust paint flow in real time based on environmental sensors. Jinho felt excitement building. Can you write that program? Yes, but I need accurate real-time environmental data from inside the spray booths. The facility has external weather sensors, but not enough internal monitoring. The workers know the conditions, Jinho said. They can tell us which booths feel more humid, which ones are warmer. We can use their observations to place sensors in the right locations. Over the next 2 days, Jinho and Dr. Mitchell worked together closely. She designed an adaptive control system. He worked with paint line operators to identify where additional sensors were needed. She wrote complex algorithms. He tested the new system during actual production runs and provided feedback. The operators appreciated being included in the solution. Carlos told Jinho, "This is the first time anyone asked our opinion instead of just telling us we were wrong about what we observed." On the 3rd day, they ran a full test. The new adaptive system monitored environmental conditions in real time. When humidity increased, it automatically adjusted paint viscosity. When temperature changed, it modified spray patterns. The system responded to actual conditions instead of assuming perfect conditions. The results were remarkable. Every car that came through the line had perfect paint coverage. No thin spots. No uneven coating. The consistency was better than it had been in months. Robert Torres, the facility manager, was amazed. "How did you do in 3 days what our team could not do in a month?" Dr. Mitchell smiled. "We combined different approaches. Technical analysis and practical observation. Neither would have worked alone." On the flight back to Detroit, the tension between Jinho and Dr. Mitchell was gone. They sat together reviewing their notes and discussing the project. "I owe you an apology," Dr. Mitchell said. "In Detroit, I dismissed your observations because they did not fit my mental model of the problem. I was so focused on proving I was right that I could not see I was wrong. I understand, Jinho replied. You felt I made you look incompetent. That was not my intention. I know that now. But at the time, I felt threatened. I spent 10 years in university earning my degrees. I published research papers. I worked on advanced projects. Then you solved a problem in an hour that I could not solve in 4 days. It made me question my own value. Jinho thought carefully about his response. Your degrees and knowledge are valuable. My experience is valuable. We were both right and both wrong. You had the technical ability to create the solution. I had the practical insight to identify the real problem. We needed each other. Dr. Mitchell nodded. In engineering school, they taught us that problems have technical solutions. Find the right formula, write the correct code, design the proper system. But they never taught us to talk to the people actually doing the work. They never taught us that human observation matters as much as sensor data. And nobody ever taught me about algorithms or fluid dynamics. Jinho said, I could identify the problem, but I could not create the adaptive control system you designed. That required your expertise. They sat in comfortable silence for a while. Then Dr. Mitchell spoke again. Can I tell you something personal? Of course. I am a woman in a male-dominated field. Do you know how hard I had to work to be taken seriously? In engineering school, professors assumed I was less capable than male students. In my career, I constantly had to prove I belonged. When you outsmarted me in Detroit, it felt like confirmation that I did not deserve my position, that I was an imposter. Jinho had not considered this perspective. I did not mean to make you feel that way. I know. But it helped me understand something. I was doing to you what others did to me. Dismissing you because of who you are rather than listening to what you had to say. I judged you by your job title instead of your abilities. That was wrong. We both learned something, Jinho said. Maybe that is the real value of this partnership. Not just solving problems, but learning to work across different worlds. Dr. Mitchell extended her hand. Partners? Jinho shook it. Partners. When they landed in Detroit, Jinho felt different. He had started this journey thinking he needed to prove mechanics were as smart as engineers. But that was the wrong goal. The real achievement was showing that different types of knowledge could work together. Neither was superior. Both were necessary. Dr. Mitchell felt different too. She had spent her career trying to prove she belonged in engineering. But now she realized belonging was not about being better than others. It was about contributing something unique. Her technical skills combined with Jinho's practical wisdom created solutions neither could achieve alone. The partnership that started with resentment had become genuine collaboration. And this was just the beginning. News of the Tennessee success spread quickly through the company. David Chen, the VP of Operations, was impressed. 2 facilities with major problems, both solved by pairing an experienced mechanic with a trained engineer. He saw potential for something bigger. 2 weeks after Jinho and Dr. Mitchell returned from Tennessee, David called them to corporate headquarters in Chicago. They sat in a large conference room on the 20th floor. Through the windows, they could see the city skyline. David stood at the front of the room with a presentation on a large screen. I have been thinking about what you two accomplished. You proved that combining different types of expertise creates better solutions. I want to make this approach standard across all our facilities. He clicked to the next slide. I am launching the Integrated Solutions Program. We will create teams at every factory that pair engineers with experienced technicians. When complex problems arise, these teams will work together from the beginning, not just after traditional approaches fail. Jinho felt his heart beat faster. This was much bigger than he expected. Dr. Mitchell looked equally surprised. You two will lead this program, David continued. Dr. Mitchell, you will design the training curriculum for engineers. Jinho, you will train technicians. Together you will travel to facilities, set up new teams, and show them how collaboration works. You will be the model everyone else follows. How many facilities? Dr. Mitchell asked. We have 47 manufacturing facilities worldwide. I want integrated teams in all of them within 1 year. Jinho could barely process this information. Traveling to 47 facilities? Training hundreds of people? This was far beyond anything he imagined when he first noticed the ventilation problem in Detroit. Over the next 3 months, Jinho and Dr. Mitchell became traveling partners. They flew to factories in Mexico, Canada, and across the United States. At each location, They taught engineers and technicians how to work together. Jinho's training sessions focused on observation and communication. He taught engineers to spend time on factory floors, to talk with operators to notice patterns that computers might miss. Do not just trust your data, he told them. Trust your eyes and ears too. Walk the entire production line. Ask questions. Listen to the people who work there every day. Dr. Mitchell's sessions taught technicians basic engineering concepts. She explained how to read technical diagrams, understand data analysis, and communicate observations in ways engineers could use. You see things that sensors cannot detect, she told them. But you need to describe what you see clearly. Be specific. Write down your observations. That makes them more useful to engineers. The program had immediate impacts. At a facility in Ohio, an integrated team solved a persistent packaging problem in 2 days. At a plant in Mexico, they identified and fixed a robotic assembly error that had puzzled engineers for weeks. Success stories multiplied, but not everyone welcomed the changes. At a facility in Arizona, the local engineering manager, Frank Morrison, openly criticized the program during Jinho and Dr. Mitchell's visit. "This is a waste of time and money," Frank said at a department meeting. "We hire engineers because they have expertise. We hire technicians to follow instructions. Mixing these roles creates confusion and inefficiency. Everyone should stay in their lane." Dr. Mitchell responded calmly. "Do you have any major unsolved problems at this facility?" Frank hesitated. "We have an ongoing issue with a cooling system, but my team is working on it." "How long have they been working on it?" 3 weeks. May we take a look?" Jinho asked. Frank clearly did not want to agree, but David Chen had given the Integrated Solutions Program authority to investigate any problem. Frank reluctantly led them to the cooling system. Jinho spent an hour observing and talking to the technicians who maintained the cooling equipment. Dr. Mitchell reviewed the technical specifications and diagnostic reports. They compared notes and identified the issue within 2 hours. The problem was a combination of incorrect sensor placement and unexpected heat sources that the original design had not accounted for. Within a day, the cooling system was fixed. Frank said nothing after that. His silence spoke volumes. Some people opposed the program because they felt threatened by change, but results were hard to argue with. The media began paying attention. A journalist named Rebecca Park from Manufacturing Today magazine contacted Jinho for an interview. She had heard about the program from multiple sources and wanted to write a feature story. Jinho was nervous about the interview. He had never spoken to the press before. Dr. Mitchell coached him. "Just be yourself. Tell the truth. Explain what we are trying to accomplish." The interview took place at the Detroit factory where everything started. Rebecca was professional and friendly. She asked Jinho about his background, his approach to problem solving, and his thoughts on the Integrated Solutions Program. "Why do you think engineers and technicians have not worked together like this before?" Rebecca asked. Jinho thought carefully. "I think people build walls between different types of work. They say this is engineer work, this is technician work. They forget that we all have the same goal. Make good products, keep the factory running, help the company succeed. When you focus on the goal instead of protecting territory, collaboration becomes natural." What advice would you give to other companies considering similar programs? Start small. Pair one engineer with one experienced technician on a real problem. Let them figure out how to work together. Do not force it. Just create the opportunity and see what happens. If it works, expand from there. The article appeared 2 weeks later. It was the cover story. The headline read, "The Mechanic Who Changed Manufacturing: How Jinho Park and Dr. Sarah Mitchell Are Breaking Down Workplace Barriers." The article went viral in manufacturing circles. Other automotive companies called asking about the program. Aerospace companies, electronics manufacturers, and food processing plants wanted to know more. Jinho started receiving invitations to speak at industry conferences. His first speaking engagement was at a manufacturing summit in Las Vegas. 500 people attended. Jinho stood backstage terrified. He had prepared a presentation, but his hands were shaking. Dr. Mitchell found him before he went on. "You are going to be fine," she said. "These people want to hear from you. Just talk to them like you talk to workers on the factory floor. Be honest, be yourself." Jinho walked onto the stage. The lights were bright and the crowd looked enormous. He started speaking, his voice shaky at first. But as he told the story of the welding problem, His confidence grew. He was not giving a corporate presentation. He was just explaining what happened. The audience listened intently. When he finished, they gave him a standing ovation. During the question period, a plant manager from an appliance manufacturer raised his hand. "We have been trying to implement something similar at our facilities, but we are facing resistance from both sides. Engineers feel undermined. Technicians feel intimidated. How did you overcome this?" Jinho thought about his early tension with Dr. Mitchell. Resistance is normal. People protect what they know. Engineers spent years learning their skills. Technicians spent years building their experience. Both groups worry about losing value or respect. You cannot force them to work together. You have to show them why it benefits everyone. He paused. In my case, I needed to prove I respected Dr. Mitchell's knowledge even though she initially dismissed mine. She needed to see that collaborating with me did not diminish her expertise. It enhanced it. That mutual respect took time to build. You need patience. After his speech, people lined up to talk with Jinho. Plant managers, engineers, technicians from various companies. They shared their own struggles with workplace silos. Many said his story inspired them to try new approaches. Back home in Detroit, Jinho's life had changed dramatically. He no longer worked regular shifts at the factory. He spent most of his time traveling, training, and speaking. The salary increase was significant. He and Sunyi were able to help their children with college expenses and pay off their mortgage early. But the attention was overwhelming sometimes. Jinho missed the quiet routine of fixing machines. He missed the familiar faces of co-workers he had known for decades. Success brought opportunities but also stress and pressure. One evening, Jinho sat with Sunyi in their backyard. It was a warm summer night. Fireflies blinked in the darkness. "Do you regret choosing this path?" Sunyi asked. Jinho considered the question. "Sometimes I miss the simple life. Just going to work, doing my job, coming home. No travel, no speeches, no pressure. But then I think about all the technicians who told me they feel more respected now. All the engineers who learned to listen better. All the problems that got solved because people worked together. How can I regret that?" "You changed more than just how factories solve problems," Sunyi said. "You changed how people think about different types of work. That is important." By the end of the year, the Integrated Solutions Program was implemented in all 47 facilities. The results were impressive. Production efficiency across the entire company increased by 23%. Quality defects dropped by 31%. Employee satisfaction scores rose significantly. Most importantly, workers at all levels reported feeling more valued and heard. The program saved the company over $200 million in its first year. This financial success convinced even the skeptics. David Chen presented these results to the board of directors, who immediately approved expanding the program further. But not everything was positive. Some facilities struggled to make the program work. Old hierarchies were hard to break. Some engineers continued to dismiss technician input. Some technicians felt uncomfortable challenging engineer decisions. Cultural change was slow and uneven. Jinho and Dr. Mitchell found themselves troubleshooting not just mechanical problems, but human relationship problems. They learned that changing how people think and work together was much harder than fixing machines. At one facility in California, they encountered a particularly difficult situation. The integrated team there had completely broken down. The lead engineer, Dr. Thomas Chen, and the senior technician, Maria Rodriguez, refused to work together. Both were competent professionals, but their personalities clashed. Jinho met privately with Maria. "What is the problem?" "Dr. Chen treats me like I am stupid," Maria said, frustration clear in her voice. "He explains things in a condescending way. He ignores my suggestions. He makes me feel worthless." Dr. Mitchell met with Dr. Chen. "What is your perspective?" "Maria resists every new approach," Dr. Chen said. "She wants to do things the old way. She questions my decisions constantly. I cannot work effectively when someone undermines my authority." Jinho and Dr. Mitchell recognized this pattern. It was similar to their own early relationship. They spent a week at the California facility, not fixing technical problems but mediating between Maria and Dr. Chen. They arranged for Maria and Dr. Chen to work on a small, non-critical project together. Something with low pressure, they made both commit to specific communication rules. Dr. Chen had to ask Maria's opinion before proposing solutions. Maria had to explain why she questioned decisions instead of just resisting. Slowly, painfully, the relationship improved. Maria and Dr. Chen learned to work together, not as friends, but as professional colleagues who respected each other's contributions. It was not perfect, but it was functional. This experience taught Jin-Ho an important lesson. The Integrated Solutions program was not just about solving technical problems. It was about changing workplace culture, and culture change required constant attention, patience, and sometimes difficult conversations. As the program grew, Jin-Ho realized his role was evolving. He was no longer just a mechanic who solved a problem. He had become a symbol of something larger. Blue-collar workers across industries saw him as proof that experience and observation mattered. Engineers saw him as a reminder to stay humble and open to different perspectives. The attention was flattering but also heavy. Jin-Ho carried the hopes and expectations of thousands of workers who wanted their knowledge to be valued. That responsibility weighed on him. One evening, Jin-Ho returned to the Detroit factory, not for work but just to visit. He walked through the familiar spaces, touching machines he used to maintain. A young apprentice named Chris Johnson was working late. Chris was 20 years old, just starting his career. "Mr. Park, I did not expect to see you here," Chris said, "just visiting." "I miss this place sometimes." Chris set down his tools. "Can I ask you something?" "Of course. Do you ever regret how everything changed? Before all this, you were just a regular mechanic. Now you are famous. Was it worth giving up the simple life?" Jin-Ho looked at the production line. Machines hummed their familiar rhythm. "That is a good question, Chris, a question I ask myself sometimes. I miss turning wrenches. I miss the quiet satisfaction of fixing things. But I'm proud that workers like you will be heard and respected. That is worth the sacrifice," Chris nodded thoughtfully. "My supervisor actually asked my opinion on a problem last week. That never happened before the program started. I felt like my experience mattered. That is exactly why it was worth it," Jin-Ho said. The program continued to expand. More success stories emerged. More lives changed. Jin-Ho and Dr. Mitchell kept traveling, teaching, and building bridges between different types of expertise. They had started something that was bigger than either of them now. Something that would outlast their own careers. But the journey was far from over. New challenges waited ahead. 6 months passed since the Integrated Solutions program launched across all company facilities. The results continued to exceed expectations. Production numbers improved steadily. Workers reported higher job satisfaction. Even the initial skeptics had to admit the program worked. In February, the company held its annual awards ceremony at a luxury hotel in Chicago. This event traditionally honored executives and high-level managers. Engineers sometimes received recognition for major innovations, but factory floor workers rarely attended. They were never considered for top awards. This year was different. Jin-Ho received an invitation to the ceremony. The letter explained that he would receive the Innovation Excellence Award, the company's highest honor. Past recipients included the engineers who designed the company's hybrid engine and the team who developed advanced safety systems. Jin-Ho would be the first non-engineer to receive this award. He flew to Chicago with Soon-Yi. She bought a new dress for the occasion. Jin-Ho wore a suit that felt uncomfortable and stiff. He was used to work uniforms, not formal clothes. In the hotel ballroom, hundreds of people in expensive outfits mingled and talked. Jin-Ho felt out of place. Dr. Mitchell found him standing awkwardly near the entrance. She had been promoted to Director of Collaborative Engineering, a newly created position. She wore a professional business suit and moved confidently through the crowd. "Nervous?" she asked Jin-Ho. "Very. I do not belong here. You belong here more than anyone. Come on, let me introduce you to some people." The ceremony began with dinner. Jin-Ho sat at a table with other award recipients and their families. The CEO, Richard Morrison, gave a speech about innovation and excellence. Then the award presentations began. When Jin-Ho's name was called, his heart pounded. He walked to the stage slowly. The spotlight was bright. Richard Morrison stood holding a crystal trophy. "Jin-Ho Park," Richard said into the microphone, "joined our company 28 years ago as an apprentice mechanic. Through dedication and careful observation, he became one of our most valuable employees. Last year, he identified a critical production problem that had stumped our engineering team. His solution saved the company over $40 million. But more importantly, his approach inspired a new way of working that has transformed our entire organization." The audience applauded. Jinho accepted the trophy. It was heavy and beautiful, with the company logo etched into the crystal. Richard stepped back, indicating Jinho should speak. Jinho had prepared remarks, but standing on that stage, they felt wrong. He folded the paper and put it in his pocket. He would speak from his heart instead. Thank you for this honor, but I need to be honest with you. I did not solve that welding problem alone. Dr. Sarah Mitchell and her team did the hard work of implementing the fix. I just pointed them in a direction they had not looked yet. That is what this award really represents. Not one person being smart, but different people combining their different types of knowledge. He paused, gathering his thoughts. The room was completely silent. For 28 years I fixed machines. I watched, I listened, I learned. But nobody asked my opinion on big problems. I was just a mechanic. Then one day I had to speak up because the problem was too important to stay quiet. Dr. Mitchell could have dismissed me. She had every reason to. I had no degrees, no credentials. But she listened. She tested my idea. And together we found the answer. Jinho looked out at the audience. He saw executives, engineers, managers, but he also saw a few factory workers who had been invited to watch. I accept this award on behalf of every worker who knows things they never get to share. Every technician who sees problems but feels like nobody will listen. Every person whose experience matters but gets overlooked because they do not have the right titles or degrees. This award says that knowledge comes in many forms, that experience matters as much as education, that we all have something valuable to contribute. The applause was thunderous. People stood up. Jinho saw Sunyi crying tears of pride. Dr. Mitchell was applauding enthusiastically. Even some of the executives who had initially opposed the program were standing and clapping. After the ceremony, the crowd surrounded Jinho. People wanted to shake his hand, take photos, hear his story. He felt overwhelmed by the attention, but he also felt something else. Validation. Not just for himself, but for all the workers like him who had spent careers feeling invisible. A junior engineer named Amanda Chen approached him. Mr. Park, your speech meant a lot to me. I am new to the company. In engineering school, they taught us that we would have all the answers. But my first project was a disaster because I did not listen to the technicians who actually understood the equipment. Your program taught me to be humble, to learn from everyone. Thank you for that. An older technician named Robert Williams also waited to speak with Jinho. I have worked in factories for 35 years. I always felt like my knowledge did not matter, like I was replaceable. Your story changed that. My supervisor now asks my opinion. It makes me proud of my work again. These conversations continued for hours. Jinho realized his story resonated because it touched something fundamental. In every workplace, people create hierarchies. Some jobs are valued more than others. Some voices are heard while others are ignored. The Integrated Solutions program challenged those hierarchies. It said that different types of knowledge were equally valuable. The media attention intensified after the award ceremony. Major business publications wrote about Jinho and the program. Harvard Business Review published a case study. Manufacturing Today did a follow-up article. Jinho appeared on a podcast about workplace innovation. Other companies began implementing similar programs. An aerospace manufacturer in Seattle created integrated teams pairing engineers with assembly technicians. A pharmaceutical company paired scientists with production operators. A technology company brought together software engineers and customer support staff. The idea spread across industries. Jinho received letters from workers around the world. A factory worker in Germany wrote, "Your story gave me courage to speak up about a problem I noticed. Management listened, and we fixed an issue that had cost money for years. Thank you for showing that our observations matter." An electrician in Australia wrote, "I showed my kids your story. They were embarrassed that their dad did not go to college. Now they understand that trade skills are valuable. You changed how my family sees my work." These letters moved Jinho deeply. He never imagined his simple observation about a ventilation system would create such ripples. But he understood now that his story represented something bigger than one person or one problem. It represented a shift in how people thought about work, knowledge, and respect. Business schools began teaching the Park-Mitchell approach as a case study in organizational collaboration. Students analyzed how breaking down silos between different types of expertise created innovation. Professors debated whether this approach could work in other contexts beyond manufacturing. But the program faced ongoing challenges. Not every integrated team succeeded. Some facilities reverted to old hierarchies when facing pressure or tight deadlines. Budget cuts threatened training programs. Some managers saw the program as extra expense rather than investment. Jin-Ho and Dr. Mitchell worked constantly to maintain momentum. They traveled to struggling facilities, mediated conflicts, and reminded people why the program mattered. Cultural change was never easy or quick. It required continuous effort. At a facility in South Korea, they encountered their biggest challenge yet. The Korean manufacturing culture emphasized strict hierarchy and respect for credentials. The facility manager, Director Lee Min-jun, had worked his way up through traditional management channels. He believed in clear separation between different levels of workers. When Jin-Ho and Dr. Mitchell arrived to implement the program, Director Lee was polite but skeptical. This American approach may work in Detroit, but Korean culture is different. Workers here respect hierarchy. They do not question engineers. That is how we maintain order and efficiency. Despite being Korean American, Jin-Ho struggled with the formal business culture. The Korean engineers viewed the collaborative approach as disrespectful. The technicians were afraid to speak up, even when Jin-Ho encouraged them to share observations. The facility had a serious problem with a newly installed automated assembly system. Millions of dollars of equipment sat idle because the system failed during production runs. Director Lee had given the problem to his engineering team. After 3 weeks, they had not found a solution. Jin-Ho remembered his parents' teachings about Korean culture. He adjusted his approach. Instead of challenging hierarchy directly, he showed proper deference while still advocating for worker input. He met privately with night shift technicians away from management scrutiny. The technicians revealed crucial information. The assembly system was designed for components manufactured to European specifications. But the Korean plant used locally sourced parts with slightly different tolerances. Nobody had reported this because they assumed the engineers already knew. Speaking up might suggest the engineers had made a mistake, which would be disrespectful. Jin-Ho brought this information to Dr. Mitchell. She recalibrated the system parameters to accommodate the actual component specifications rather than the theoretical ones. The assembly line ran flawlessly after the adjustment. Director Lee was impressed. More importantly, he learned an important lesson. I have been a manager for 20 years. I thought I knew everything about how factories should work. But I was wrong. Listening to all workers, regardless of rank, makes us stronger. This program has value even in Korean culture, perhaps especially in Korean culture, where we have been too rigid about hierarchy. This breakthrough in South Korea validated that the program could work across different cultures. It was not just an American idea. It was a universal principle about respecting different types of knowledge. By the end of Jin-Ho's second year leading the program, the impact was undeniable. The company had saved over $200 million through improved efficiency and reduced defects. Employee retention improved significantly. Workers felt more engaged and valued. The company's reputation as an innovative employer attracted top talent. Dr. Mitchell received a major promotion. She became Vice President of Innovation, overseeing not just the Integrated Solutions Program, but all company initiatives related to new approaches and methods. Her career had flourished since partnering with Jin-Ho. Jin-Ho was now 53 years old. The travel and pressure were exhausting. He had achieved more recognition than he ever imagined possible, but he felt tired. He missed the simple days of just fixing machines. One quiet afternoon, Jin-Ho returned to the Detroit factory, not for official business, just to walk the floor. He wanted to see where his journey began. The welding station looked the same. The robots hummed their familiar rhythm, but something was different. The culture had changed. He watched as a young engineer and an experienced technician stood together examining a machine. They were having an animated discussion, clearly disagreeing about something. But their disagreement was respectful. The engineer was listening to the technician's observations. The technician was asking questions about the engineer's analysis. They were working together as equals, combining their different perspectives. This scene, repeated throughout the factory, was Jin-Ho's real legacy. Not the awards or media attention, not the money saved or efficiency improved, but this fundamental shift in how people worked together and valued each other. Young apprentice Chris Johnson spotted Jin-Ho and walked over. "Mr. Park, good to see you. How are things going, Chris? Really good. I was just in a meeting where my supervisor asked my opinion about a new process. Can you believe that? They actually wanted to know what I thought. That never would have happened before you changed everything. Jinho smiled. I did not change everything. I just helped people see what was always there. Your knowledge and experience were always valuable. How people recognize it. Do you regret how your life changed? Chris asked. You travel constantly now. You give speeches. You are kind of famous. Was it worth giving up working with your hands? Jinho thought carefully before answering. This question haunted him sometimes. He did miss the simple satisfaction of fixing things. He missed the routine and familiarity of regular factory work. Success had brought stress and pressure he never wanted. Sometimes I miss the old days, Jinho admitted. I miss turning wrenches and solving problems with my hands. I miss knowing every worker's name and every machine's personality. But then I think about you, Chris. You feel valued now. Your observations matter. That would not have happened without this program. He paused, looking at the production line. I think about all the other crises out there. In factories across the world. Workers who have knowledge and ideas but never get heard. If my story helps even a few of them get the respect they deserve, then yes, it was worth it. Chris nodded thoughtfully. My little sister wants to be an engineer, but she also wants to work with her hands like our dad does. She used to think she had to choose. Now she understands she can combine both. That is because of what you showed is possible. This was what truly mattered, not just solving one problem or even creating one program, but changing how an entire generation thought about work, knowledge, and respect, breaking down the walls between different types of expertise, showing that innovation comes from combining perspectives, not from keeping people in separate boxes. Jinho spent another hour in the factory, just observing. He saw the fruits of what he and Dr. Mitchell had started. Engineers and technicians working side by side. Respect flowing in all directions. Problems being solved faster because everyone's knowledge was valued. As the sun set outside the factory windows, Jinho prepared to leave. He had a flight to catch. Another facility needed help implementing the program. Another group of engineers and technicians needed training. The work continued, but before leaving, Jinho stopped at his old workstation. His toolbox still sat there, maintained by Chris now. Jinho opened it and looked at the familiar tools. Each one had a story. Each represented years of learning and experience. He picked up a worn wrench. Old Robert had given him this wrench on his first day 28 years ago. Take care of your tools and they will take care of you, Robert had said. Jinho set the wrench back carefully. His tools were in good hands with Chris. The next generation would carry forward not just the tools, but the knowledge and the culture of respect they represented. Walking out of the factory, Jinho felt at peace. His life had changed in ways he never expected or planned. He had become a symbol of something larger than himself. That was heavy sometimes, but it was also an honor. The story that shocked the world was not really about a mechanic outsmarting engineers. It was about breaking down barriers. It was about recognizing that knowledge comes in many forms. It was about listening to people we too often ignore. It was about combining different perspectives to create something better than any one person could achieve alone. Jinho did not solve one problem. He started a movement, and that movement would continue long after he retired. Other workers would speak up. Other engineers would listen. Other companies would learn. The ripples would keep spreading. As Jinho drove home through Detroit streets, he thought about the question Chris had asked. Was it worth the sacrifice? Yes. Absolutely yes. Because the greatest achievements are not the ones that make us famous or rich. They are the ones that make the world a little bit better for the people who come after us. They are the ones that prove every person has value. They are the ones that show respect and collaboration can overcome division and hierarchy. That was Jinho's legacy, not a trophy or an award or a business case study, but a simple truth that changed everything. When we listen to each other, when we respect different types of knowledge, when we work together across boundaries, we can accomplish remarkable things. One mechanic noticed a pattern that computers missed. He found the courage to speak up. He insisted on being heard. And because of that simple act of observation and courage, thousands of workers around the world would be heard and valued. That was what truly shocked the world. Not that a mechanic was smart, but that combining different types of wisdom creates innovation, that respect flows in all directions, that every person, regardless of credentials or title, has something important to contribute. Jin-ho Park went back to his modest home where Soon-yi waited with dinner. He was tired but satisfied. Tomorrow he would fly to another factory. There would be more challenges, more skeptics, more difficult conversations. The work of changing culture was never finished. But tonight he was just Jin-ho. A mechanic who loved his work. A husband who loved his wife. A father who tried to make his children proud. A worker who believed that everyone deserves respect. And sometimes that is enough to change the world.